Let the function map natural number to natural number be defined as. So we have f of n to be equal to n plus 1 by 2 if n is odd, and we have it to be n by 2 if n is even. And it's mapping natural number to natural number. So let's have a look at the output. So as you can see, I have expressed the same. So f mod 2, this is basically telling if the result on dividing x with 2, if it's 1, then return this particular expression by solving it, obviously. If not, solve this and send the answer. So basically we have typed in the same thing what is given in the question, and we end up with the following diagram. So do you guys think it's 1 1? Clearly not. See, if I have an input of 1, I get an output of 1. If I have an input of 2, as you can see over here, even then I get an output of 1. When it's 3, it is 2. When it's 4, it's 2. When we have an input of 5, the output is 3. When we have an input of 6, the output is 3 again. Right? So this would be not 1 1. What does the question state? Whether the function is bijective? Clearly not, because it's not 1 1. Right? But it is on to. So I'll just write that for the sake of knowledge. Actually, answer is, since it's not 1 1, it's not bijective. So for n equal to 1, let me change the color. For n equal to 1, what do we have? F of 1 is equal to 1 plus 1 by 2. So this is equal to 1. For n equal to 2, f of 2 will be equal to 2 by 2, which 2 is equal to 1. Right? Therefore, f of n is not, underlying not, 1 1, as input of 1 comma 2 are pointing to same output, and thus f of n is not bijective. So this would be your answer for the given question. Is it onto? Actually, it's onto. Okay, I'll just show the part of writing how to prove onto. Again, this is not actually asked, because we just have to talk about, is it bijective? Clearly it's not. So we can continue the answer. Actually, we should not be, because, well, it's not asked. So is it onto? Clearly it is, because we can get every possible output in this particular codomain. Okay, so how do we put it across? So we'll tell let A represent an arbitrary value. Again, I repeat, this is only meant for understanding purpose. This is not part of your answer, for the given question at least, at codomain. If they ask a question like, prove that following is 1 1 but no, onto but not 1 1, then you guys have to be writing this, not for the given exact question. So now, then the case A is odd. So there are two different cases. So we're taking A representing arbitrary element in the codomain. So when A is odd, f of n will be equal to A, and we have n plus 1 by 2 is equal to A. Therefore, n is equal to 2A minus 1. Case when A is even. Then we have f of n is equal to A, n by 2 is equal to A. Therefore, n is equal to 2A. Next, we have two expressions, 2A minus 1 and 2A. What can we talk about that? Well, if I have A to be all natural numbers, the expressions 2A comma 2A minus 1 will result in natural number. Therefore, f of n is onto. Okay, emphasis on the word is. Do you guys agree? So when we have a function which is not 1, 1, clearly it's not bijective. But in this case, I just proved an extra bit. So you guys can answer a bit more tougher question if they happen to ask, right? So now you guys can copy, pause and copy.